Good morning, everybody. Is everybody okay? Yeah? Well, thank you for staying alive. First announcement, you have very nice t-shirts and they're on sale today. If you buy one, 10 euros, then you're allowed to buy a second one. Don't forget, and please. All right. First speaker, he has a zoology degree. He is in the aquarium industry for 13 years with the Sea Life company. He is interested in transportation and breeding of fish. And he listens to all kinds of music. He already has his tickets for the Glastonbury Festival 2014. Please welcome Chris Brown.
Thank you. Okay, thank you. My name is Chris Brown. I work at Sea Life in Weymouth, and today I'm going to be talking about the project Cyanide-Free Seas that we set up earlier this year. Just before I start, a couple of bits. Apologies that Ricardo Collaudo from the University of Aveiro couldn't make it today. Hopefully he'll join us next time when we do an update on this project. Thank you to all of you who have actually turned up this morning. I appreciate that a lot. And thank you very much to the Reading Committee for allowing me to talk today. If you don't mind, I'd like to start, if you could indulge me by allowing me to ask you some questions, just to get started. A very simple one to start. Raise your hand if you love the underwater world and would like to see what you can do to protect it. Okay, excellent. We're warmed up. Put your hand up if, for the more observant of you, you wondered why the hell there's a waste bin in the middle of the stage. There's a few of you, good. Well, it's very simple. It's going to explain what's being wasted, and hopefully you'll see that through the talk. So, okay, so slightly harder questions then. Put your hand up if you would like to see the end of the use of cyanide to catch fish. Okay, excellent. I'm pleased you all agree with that one. Now put your hand up if you'd like to take away a small fisherman family's way of earning money. So I'll say it again. Put your hand up if you'd like to take away a small fisherman family's way of earning money and leave them to only resort to things like dynamite fishing. Okay, so no one agrees with that. And I think that kind of simple example shows how conflicting the issues can be. There's no simple solution. You can end cyanide fishing, but then you're going to cause other issues. So the one thing I do know is that we can't just ignore the problem. So to start off with then, I'd just like to explain two ways that I've learnt from people about how fishermen actually catch fish using the cyanide thing. Sorry, there is one more thing I wanted to explain about as well. Actually, on the flight across here, I found this article. I think it's in the Telegraph. This was in Zimbabwe just recently. They've actually caught poachers taking large buckets of water right out into the middle of the savannah. Then they add cyanide to the water, and then the elephants come in and drink their cyanide water, and then they're found dead all around where the cyanide water's been drunk. And it's shocking. There's 2 or 3 elephants here, a mother and a baby. But also the predators come and then eat the elephants, and then they die as well. So there's just like a whole series of carcasses around there. Very sad. So it's quite a simple process. The fish, of course, Nemo or whatever, goes and hides within the coral, and a fisherman comes to collect it. They have a volume of, it's basically a couple of tablets of cyanide mixed in with water, fresh water or salt water. And they literally spray it into the corals like that. And this is actually from a scientific paper, which I'll talk a bit more about later on, which actually tells you how the fish reacted when they did it. So during the pulse exposure to cyanide, at both tested concentrations, all the fish displayed frantic swimming and strong gasping behavior, followed by a loss of balance, cessation of swimming. Specimens basically rested motionless at the bottom of the container, and finally a complete loss of respiratory activity. After about 30 to 50 seconds of the beginning of the pulse exposure, And then 1 and 2 of the specimens, respectively, of both different doses, did not recover from the anaesthesia, and they died within 30 minutes following the pulse exposure. So that's only 2 of a larger sample. So obviously it's quite a dramatic effect. And that's one method of fishing for cyanide caught fish. But there's another method, and this is what was explained to me when I visited China earlier this year. Basically, there's a boat with an outboard motor. They fill up a drum with a volume of cyanide water, and they literally they set some set nets across near a coral kind of pinnacle like this. So they'll set some set nets like that. They'll go up current of the area, and then they'll literally pump this cyanide water across the top of the sea, and it'll literally float down into the reef. And any fish that are caught within that cyanide kind of wash will either go straight into the net where divers pick them out, or they'll float up to the surface, and then other boats will come and literally collect them from the surface. So I think you'll agree that can affect large areas of reef, and it's very sad to hear. It was particularly for the live food fish trade, so this is for people to eat, but also there's an incidental catch of ornamental fish which they keep as well. To be very clear, that was in China, and those fish would go from Hainan Island and they'd be distributed across China. So they weren't coming out into the other market, but cyanide is used extensively out throughout that area in small cases. So what's the problem with cyanide anyway? Who cares if they release cyanide? Well, basically it affects the health of things. So, and I'm sure most of you know this already, but firstly, the humans. I talked to someone recently who had tried cyanide fishing a long time ago, and the first thing that happened to them when they came out of the water, they went onto the boat, sat down, and then they were very physically and violently sick, and that was one of the effects. And I think there's a lot worse long-term effects if you continue to do this kind of fishing. Secondly, of course, the fish. There's 2 things that can happen, of course. So firstly, if the fish is affected by the cyanide, as I described earlier on, the kind of long-term effects may be that the fish continues to eat but never actually puts on any weight. Another effect could be that they have a very erratic behaviour, and you can sometimes see this in the tank. And a kind of a last effect, which is a very sad one, is they just don't seem to breed as well. And this was noted in the experiment I talked about before. They actually kept some of these clownfish, they still have them now, and they've got 2 tanks, and you can see the ones that were affected by the cyanide. They're a lot smaller, and they don't do very well. They've got very funny behaviour. Of course, the secondary effect that can happen to the fish is they simply die. So I spoke to some fishermen, they were saying up to 80% of the fish were being lost between the reefs and back to the facilities. This was in China. So, as I say, what a complete waste of fish. Now, talking about the corals as well, of course, when you spray a load of cyanide over a coral, it's going to kill anything that's living. So any invertebrates that are living on this coral, they'll die. And so that's a very sad thing. But one last thing that kind of happens is if a fish gets stuck inside the coral, they don't always float up. Sometimes they're just wedged inside the coral. So the fishermen will actually use like a kind of fork tool, and they'll snap the coral off. And again, that's very sad. That's 25 years of coral growth just gone. So this all started earlier on this year when I was lucky enough to go with the senior curator of Asia, Mike Stewart, who said he had shown me around China. And we were looking at basically supply routes. We have an aquarium in Shanghai, which is up there somewhere. And we wanted to go and explore this area here, which is basically Hainan Island. It's amazingly located, as you can see, just up there. And this is part of the whole kind of coral triangle. So we've got Vietnam, Philippines, and Indonesia. And fishermen will actually go from Hainan Island for up to a week. They'll go on trips down here, collecting in all these areas. So China was an amazing place. We had a really interesting time. Fish became art there. This was in one of the markets. Also, there's some sad things, but we were kind of expecting it. But it still kind of shocks you. So, of course, the seahorses. I did meet one fisherman who had turned into a breeder, and he actually captive bred seahorses. So he was actually supplying this trade through that as well. So there was some good news, but mostly bad. This was amazing. Just in the markets, they were selling live food, and you can choose what you want to eat. But these mantis shrimps were amazing. They'd make an amazing display. And the other thing was, just higher up, there was octopus loose in these tanks, and they were literally going between tanks to eat the other fish, which I found amazing. This was very sad again. We were looking for these particularly, but there were large bags of these ray gills everywhere. And I think these particular ones, as Andrew was talking about yesterday, are manta ray gills. I'm sorry, wrong way. And then this is what kind of blew me away the most. You've heard of tortoise shell. Well, these were turtle shell products. So you could buy what you wanted from turtles, which is very sad. But today I'm going to be talking about the live food fish trade particularly. And so we've got a couple of species here. We've got the coral trout and Napoleon wrasse or Marie wrasse. And these photos were just taken in the live food kind of markets. So you would go into the live food market and there'd just be tanks and tanks of these fish. And they're caught in all different ways, but I was also told that these particular guys particularly are caught with cyanide as well as caught with rod and line. And they're worth about 5 times the amount if they're alive, so it's very important to them. And just up here, this is where they were doing kind of fish rearing or fish farming, it's hard to say. A lot of the times it was small fish that they'd brought in and they'd just grown them up there. And basically families live inside these little houses and they look after a certain area of these fish, so they feed them every day, make sure they stay there, make sure they're doing all right. But also in there some very, very large groupers, and I think the only way you can get a grouper that large, of course, is to get it out of the wild. The thing that was particularly worrying about this situation was just the whole area around here was getting really ecologically ruined. You can imagine there's a massive biomass of people and fish living there, so it couldn't really sustain it. This isn't my diagram, but it just shows you some of the routes of the live food fish, so you can see going from everywhere, all these places, all these towns, fish are being distributed into Hong Kong, where they're then shared around for the live food market, particularly into China and some of the other countries around there. So how do you spot a cyanide-caught fish? Has anyone got any ideas of any of the symptoms you might see? Anyone got? You can feel free to shout them out if you've got any ideas. I suppose that's part of the problem. There isn't really a clear way of spotting a cyanide-caught fish. And there are tests, but most of them, well, all of them, involve killing that fish. So you won't be able to test your fish that you've got back in your aquarium. But these guys, when I went to the facility, the fish supplier told me that all of these fish had been caught with cyanide. So they'd come in a few days before. They'd been on a long boat ride out from Hainan Island, and they just brought these in. And these represented what was still alive after they'd come back after 5 days traveling. The one really important thing to notice is that they all look perfect. They looked in really good condition. I've heard of fish looking pale and other fish looking very bright from the cyanide use. But the one thing that was very obvious is they're just not losing the scales. Of course, they don't need to because they've been treated with cyanide. They'll literally just float up and are very easy to catch. When we came back, we all had a talk about this. Obviously, it was very upsetting, so we wanted to know if there's anything we could do to try and help this issue. Well, we had a talk from Cairns a few years ago, and they mentioned about this test that had come out, and since then we hadn't really heard much about it. So we got in contact with the authors. It was basically a very simple idea. This is Ricardo Collaudo that I talked about earlier, and this is Marcela Vaz, who's doing a PhD on cyanide, basically cyanide screening. The idea was, with a freshwater fish, if you treat them with cyanide, that fish will eventually excrete that cyanide as thiocyanate in its urea. So what happens with marine fish? The idea was, with a freshwater fish, it happens so quickly that as soon as the fisherman's caught it, then they kind of lose that thiocyanate and you can't test for it. But of course, a marine fish holds on to its urea for a lot longer, so it carries on excreting it. So the test was very simple. They got 3 samples of fish, put them into these little kind of containers like this, and then they pulse exposed them. So one set they did full dose cyanide, one set they did half dose cyanide. This is kind of incidental on what they'd found out people used to treat fish. And then another set they didn't do anything. And basically every day they tested that water to see what was happening. So they changed the water every day and then retested it to see the levels of thiocyanate being given off in the urea. And of course the test showed that the ones that had been treated with cyanide gave off the thiocyanate, so it was a real result. But since then, not a lot has happened about this test. So we went out to visit them in Portugal, and kind of the Cyanide-Free Seas project was born. And the idea was very simple. We have 50 aquariums around the world, so there's a lot of sources, and we're working in a lot of regions, so we can get samples from all different places. And the idea was just to keep feeding them the samples so that they can continually develop the test. So there's all kinds of things that could go wrong with a test like this. For example, it's just been done on clownfish on a very small set of samples. So what happens when you use a larger fish? What happens when you use a different species of fish? Do certain fish give off thiocyanate? You know, there are all sorts of complications. And we spoke to our suppliers about it and got the support from a whole load of our suppliers and talked about this. And basically we decided we'd do it for a year to see where we get to. As you can see again, these are more fish in that same supplier that were again caught with cyanide. There was an article about the test which was very helpful for us because it put us in contact with a lot more people who were interested in the subject. This is a typical supplier. Just wanted to show you the process to kind of show you how simple it was. I'll try and speed up a bit as well. So, very simply, the fish comes in from the supplier. We then acclimatise it to artificial salt water. We'll then net move it into a new tank. We'll leave it there for 24 hours. And after 24 hours, we'll take a small sample of water from there and check for thiocyanate. And that's the basic test. We also take the artificial salt water before the fish has been in it to ensure that hasn't got any thiocyanate in to start with. So the results. Well, after 75 samples, and I'm not going to go through the exact results, I'm just going to tell you what we found so far. After 75 samples, 41 of them were completely clean. 12 of them were undefined, which means there's low level of something in there, and it's very hard to see because there's a few things masking it. But when there's a clear dose of thiocyanate, it's very easy to see, and that's what we see here on the 10. So for some reason, 10 of them have got thiocyanate in, and that's what we really need to explore now, to go into more detail and do more tests to see if we can determine why that's there. Just taking you through a few of these, you can see these were all the negative results, so I'm just taking you through them. This is captive bred clownfish, so you knew that they shouldn't be positive. And again, European fish that we tested as well. So as I said, it was tested all around the world, so we tried lots of different places. So the basic issues. Sorry, one second. Yeah, so the basic issues, natural salt, it doesn't work in natural salt. A few people have talked to me about this. We don't know if it's an inorganic or an organic problem, basically, but there's things in natural salt that mask it. So you can still see when there's a very strong positive, but there's other bits that get in the way. The test isn't portable, so at the moment you have to go to a laboratory to get the test done, which means you can't use it in the field, so it's no good at the moment for that. The idea is long-term, hopefully there can be some kind of pocket test, but whatever it is, it'll always eventually have to go to a laboratory to be double-checked. So on very low values, it's very hard to see. You can only see above a certain dose. And contamination from other cyanide fish. This is a real worry for everyone. What happens if, for example, you catch a load of live food fish and they're big, let's say Maori wrasses, but really big fish. They're secreting lots and lots of cyanide into the water, or thiocyanate. And then you have whatever, your clownfish next to it. Will that dose that they're kind of excreting, will that affect the clownfish? And to be fair, no one actually knows, so that's one thing that we're going to look at as part of the testing. The only thing I would say is that the kind of levels that we're getting off results would suggest that whatever it is, that fish has still been exposed to cyanide, even if it's a secondary exposure, so it still have the same kind of damage. You can see here on the photograph, these are clownfish that were actually going through the pulse cyanide in the middle of the trial. And then, of course, pollution. What happens if there's already cyanide in the area where the fish are collected from? Will that show up on a test? And I kind of come back to that same answer. If it is, then we need to at least highlight it from the test and then go back and find that out. Either way, your fish is still being treated with cyanide in some way. So I don't think I mentioned at the start, the reason that the cyanide is generally in a thing that you can actually buy is because it's used for the gold mining industry as kind of part of the extraction process. So what now? What do we do? So we're going to establish the sources of those positive tests. So what's going on? Is it our sampling technique? Are we getting one positive test and then passing it through others? You know, is it to do with coming up with a new sampling protocol that everyone around the world can use? Because at the moment, if you do this in all different regions, there can be all sorts of problems, translation problems, there can be people doing things in a slightly different way. One of the ways that we're going to deal with that is to get Marcelo Vaz from the University of Aveiro across to some of our aquariums to practice doing the sampling with our staff and to rewrite the kind of ways of doing it. Also getting in lots more fish from these locations and testing them against different suppliers and testing them from different locations will be another way that we'll be able to double check some of these things. And of course just doing lots and lots of trials, and that's what Marcelo's PhD is all about, so that we can do more research. One really important thing is working with our suppliers on traceability. So our suppliers are interested in this, and some of them have very good traceability, and for some of us it's quite difficult. And this is where we want to work together to be able to get more traceable fish. Of course, if we get a result, we then need to go back down the chain to try and determine what's going on, you know, if it's to do with the chain or if it's to do with the test, etc. And of course, the long-term goal is to establish a service for everyone to use. So what can you do? Obviously, I think this is probably all very close on everyone's minds anyway, but I'll go through it. But if you don't know where your fish are, find out where they're from. Are they from an ethical source, and are they traceable? And I think we as a group have to lead this for the rest of the industry. And of course, if we ask for this from our suppliers, we have to support our suppliers. It's going to cost more money. We can't go for the cheapest fish. We have to kind of highlight this. We've got to all accept that it's going to be more expensive to get these healthy fish and to get good traceability on fish. And so just to end with, I just wanted to say thank you very much to Mike Stewart, who was the curator in Asia, who spent all that time taking me around those places. Thank you very much to the University of Aveiro. It's basically the test that they've come up with, and they've done some amazing work on it, and they're completely dedicated and a very dynamic team. And thank you very much to the fish suppliers who have had long talks about this. And of course for the displays developments team, Rob, Robin, Emma, lots of people have helped us along the way of the test. And thank you very much to all the other people in the team that have been part of this, so especially the people providing the samples. Thank you very much.
Thank you so much, Chris. Any questions? We have time.
Thank you very much. I'm just curious to find out which other chemicals are being used for chemical fishing, like chlorine or vinegar, some other acids. Thank you.
Yeah, I think we are too. And I've heard of quinine and quite a few other chemicals being used. But I don't know much about those chemicals at the moment. So I know, as I say, quinine, and some of the other suppliers might be able to tell us of some other ones that are more suitable. I know some people were talking about using like a freshwater chemical as well to try and flush animals out, but we haven't trialled any of these and don't know anything particularly about it, but thank you.
Your initial question about do we want the poor fisherman to lose his income implemented a little bit that if we are against cyanide fishing, then we take away his income. I hope that's not true. I mean, there are many different ways of catching fishing, ornamental fish, and in specific areas there are very skilled people that catch them without any poison, and that might be depending on the fish species, but I hope there are alternatives for them.
Yeah, thank you for bringing it up. Actually, it's very good to clarify. Yeah. It's the people who are using the cyanide are not the ones that are skilled and not the ones who are well trained by some of our good suppliers, you know. It's the people who don't have that money, and often the younger people who haven't got the skills will use the cyanide freely. So what I was trying to point out is that it's no good us just coming up with a test and saying everyone use that and then just let's forget about one part of, you know, region of the world or something, and we can't just do that because there's a lot of people there that are dependent on this at the moment. And what I was saying really is we need to be part of the solution as well, and it could be that, I don't know, there's lots of ideas of ways that we could help it, but we actually need to think about that as well, and that's something that we as a group are looking into, but I'd happily help anyone else who is, and would like to work with anyone else who wants to be part of the solution as well. Thank you.
Okay, this will be the last question.
Mm-hmm.
Yeah, thank you. More just a corroborating statement, I suppose, in response to the last comment. One of the big failures that the Marine Aquarium Council had on the ground in these villages in Philippines was that the fishermen, when they went to hand collection, they started using nets. They were promised that they were going to earn more money by taking up those practices. The reality was that this was opposed by the larger wholesalers purchasing the fish. That additional benefit was not passed on, and so, you know, it's hard to justify for those fishermen to go that extra step, use the nets, catch a small proportion of the fish that they otherwise would using cyanide if they're not going to get paid more. So I just wanted to add that. Thank you.
Yeah, thanks. And just to finish with, just to be very clear, this is a test in development, and so we need to see how we go, and hopefully in a year's time we'll know a lot more and we'll be able to present again. Thank you.
Thank you, then.